Okay, good morning, students. So here today we want to evaluate what is the force exerted by a jet on a fixed inclined plate. So we have to find out if this is a fixed inclined plate. That means this is a stationary plate. It is not moving. So this is a fixed inclined plate, and here we have a nozzle. Through this nozzle, the jet of water is coming with a velocity v. Now, what is the force with which this water, which is coming with a velocity v, what force this water is exerting upon this plate? Okay, so what is the force that is being exerted by this jet on this inclined plate? Now, theta represents the angle of inclination. That means theta represents the angle between this jet of water which is coming with a velocity v. So, this jet of water and this plate, the angle between this is theta degree. Okay, now if this and this jet is having a diameter d. So this jet is having a diameter d. This is the velocity v, and the angle made by this jet upon this plate is angle theta. Now jet is coming with a velocity v, and here we have the angle theta. So this velocity v can be resolved into two components. That means by resolution of the force we have this, that the corresponding side with this angle, the component of this velocity along the adjacent side, that is the cos component. So if this is velocity v, this is angle theta. So this component of velocity will be v sin theta, and the opposite side it will be the v sin theta. So we have resolved the velocity into two components, that is v cos theta into v sin theta. Okay, and here in all the cases we are finding what is the force that is exerted by the jet on the plate along the normal direction. In the earlier cases also, when it was the vertical plate, so in case of the vertical plate we were calculating the force Fx. So here let us find out what is the force that is being exerted by this jet of water which is flowing with a velocity v. Now what is the force exerted by this jet along the normal direction to the plate? So this plate, it is having an angle theta. So you have to calculate Fn. Fn represents the normal force. So if this angle is theta, this angle will be 90 minus theta. So here also we have the opposite angle, it will be 90 minus theta. Now let us solve this concept. So here if Fn represents the force acting along the perpendicular direction, and this v is the velocity of the jet. So by resolving this velocity component, we have two different components. Along the normal direction, if the initial velocity of the jet is v, so along the normal direction, the component of this velocity will be v sin theta. So this v sin theta represents the initial velocity of the jet along the normal direction. And next we have the component of velocity, that means initial component of velocity along the direction of the plate. Okay, along the direction of the plate, the component of velocity is v cos theta. Okay, now next, when this jet of water strikes this particular plate, then that jet will flow along the direction of the plate, because we have taken all the assumption that there is no friction loss, the velocity is uniform throughout this plate. So this jet will flow, all the fluid or water will flow along the direction of the plate. So this direction or the angle made by this plate and this jet of water, this is 0 degree angle. This water is flowing along this direction. So angle made by the plate and this jet of water, that is 0 degree. So what will be the normal component of this velocity? That means final velocity along the normal direction. So there is no flow of water along the normal direction. And also the angle is 0 degree. If this represents the sine component along the normal component, if this represents the cos component, because angle theta here is 0. So along this flow we will have cos component, and along the perpendicular direction we will have sine component, and sine of 0 is 0. So final velocity of water along the normal direction will be 0. Okay, so here we have written the component of velocity v, that means the initial component of the water along the normal direction. Initial velocity along the normal direction is v sine theta, and final velocity is 0. So by taking the impulse momentum principle, by applying the impulse momentum principle, this force Fn, normal force, that is equals to change in momentum of the liquid along the normal direction. We are calculating the normal force, so you have to take the change of momentum along the normal direction. That is what change in momentum is. That is equals to mass flow rate into initial velocity minus final velocity. Momentum means what? Momentum is mass into velocity, and rate of change means with respect to the time. So we will take outside mass upon time, that is the mass flow rate, and mass flow rate is rho AV. Rho represents the density of water, A represents the cross sectional area of the jet, and V represents the velocity of the jet of water. And what here we are taking, this mass flow rate is a mass flow rate of water that is coming through this jet. Okay, so here mass flow rate of water is what? That is with respect to this nozzle or the jet. And initial velocity, that will change with respect to the direction. So in the normal direction, initial velocity is v sine theta, and the final velocity along the normal direction, that is 0. So here we will, after simplifying this, we will get the normal force, that is equals to rho A v square sine theta. Okay, so here we have calculated the normal force. Now if you want to calculate what is the force along the x direction and y direction, so the same thing is here. So this is the normal direction of the normal force. So this is the normal force, and here we have the force along the x direction, and this one represents the force along the y direction. Okay, so here we will solve this equation. So here if this angle is theta, that means here this v cos theta, v sin theta, angle between both this is 90 degree. It is perpendicular. So this angle, that means angle between v and v sin theta, that is 90 minus theta, and same is this angle, opposite angle, that will be 90 minus theta. So if you want to calculate fx, so this fx, it will be equal to, by the same concept, that means the resolution of the forces, if this is Fn, by resolving it along the x and y direction, Fx will be equal to Fn cos 90 minus theta. The adjacent side will be cos and the opposite side will be the sine component. So if this angle is 90 minus theta, that means this component will be cos 90 minus theta, and the value is Fn. We have to resolve Fn. So Fx will be equal to Fn cos 90 minus theta. Here I have written this, Fx equals to Fn cos 90 minus theta, and cos 90 minus theta can also be written as sin theta, and Fn value we have already calculated, that is rho AV square sin theta, and here this is sin theta. So value of Fx will be equals to rho AV square sine square theta. So this is the value of fx. Again coming to fy. Fy is the sine component. Okay. So Fy will be what? Fy will be equal to Fn into sine 90 minus theta. So Fy is equals to Fn sine 90 minus theta, and this sine 90 minus theta is cos theta. So by substituting the value of Fn, we get Fy equals to rho Av square sine theta into cos theta, and this sine theta into cos theta is sine 2 theta upon 2. So we have obtained the value of Fn, Fx and Fy. Next Fn, this is Fn. So we have already studied in mechanics that Fn square is equals to Fx square plus Fy square, or this force Fn equals to root over of Fx square plus Fy square. Next is we want to calculate what is the work done. So because this is a stationary plate, so in case of a stationary plate, there is no displacement. Okay, so there is no displacement, so the work done will be equals to 0 just because the plate is stationary. Okay, now you have to solve this numerical. In the numerical it is given a jet of water of diameter 75 millimeter. So diameter of the jet is 75 millimeter, convert it into meter. This jet is moving with a velocity of 25 meter per second. That means capital V, velocity of the jet is 25 meter per second. It strikes a plate, fixed plate, in such a way that the angle between the jet and the plate is 60 degree. So the angle between the jet and the plate is 60 degree. You have to find the force exerted by the jet on the plate in the direction normal to the plate. You have to calculate Fn, and in the direction of the jet, that means Fx. So here calculate Fn and Fx. So you have to write down the given data. Then what you have to find out, that means Fn equals to the formula and Fx equals to what the formula is. Then draw the diagram. After that, step by step you have to solve this question. So this is the task that you have to complete today. Okay.